Alrighty, we got ourselves a doozy here. You might notice that I've got two microcontrollers, and you might be wondering why that is. Well, I'll tell you why. First, let me explain the purpose of the lab. The purpose of the lab is to use a random number generator to cause an LED to blink that quantity of times. So the RNG is going to generate a quantity to cause the LED to blink that many times. That blinking will be sensed by a photoresistor to serve as an input for an output to the speaker. So basically, we want that photoresistor to track the number of times that the light is blinking in order to create that number of chimes on the speaker. You confused? I was. And we want to do it with the photoresistor because we could just use the RNG to probably feed both things and get them to chime and beep. But if we want to use the photoresistor as the input, as the analog symbol to create the output and not just program it to beep and flash at the same time, then we got to get creative because as it turns out, that's too many functions for just the one motherboard or whatever to handle at a time. So basically what I would have is I'd have the RNG cause that to blink and it would function normally, but it wouldn't create a speaker output and it wouldn't track, it would track the signal across the that, analog port, but not while it was running the function that caused the RNG to cause that to flash. It would stop. I could get the speaker to go, but only if I plugged the speaker basically into the constant voltage from the 5 or the 3.3 volt terminal, and then it would work normally. Like I could plug it in and out, and it would work just fine. Or even the LED, not the speaker. I mean the LED. I could plug this LED in, manually turning it on and off, and the system would function as we want it to, basically, to where the speaker chimes every time this goes high. But I couldn't do them simultaneously. So what I did was, lucky me, I've got two of these things since it was suggested to me that I might burn out one of these boards throughout the quarter. Luckily, I didn't. So I have two. I was sort of briefly looking at YouTube as to how to get them to communicate, serial communicate with each other, and it was getting a bit confusing. So then I had the idea of like, look, why don't I just program one of these boards to do one function and program one of the boards to the other? And basically that's what I got going on here. So this one's powered by the battery, and basically what this one does is it checks that analog signal, and it tracks it, and when the certain conditions are met, it kicks out the output. That's what that one does. This one creates the random number generator and the function to cause this to blink. So let's check this out. So we press the button. It should create a random number between 1 and 5. 1, 2, 3, 4. 1, 2, 2. 1, 2, 2. So here's a serial monitor, and that's tracking that. And it might be kind of hard to hear, but the thing's chiming basically at that same rate. So that was 3. So anyway, everything. First of all, I got two codes. Everything was on this code, so I didn't want to delete everything, lose stuff, so everything just got double bars to kind of just make it kind of superfluous text. But basically, we got our button and our LED blinker. That's just the output for the LED that blinks. That's what I called it. Set those up, blah, 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 void loop. This is all stuff that has to do with the analog reading and the output of the speaker chime and stuff. But that will be handled on this one here in a sec. So first things first, we want to check our push button state, check that. And if it's high, we go to the function blink. Blink down here what it does is it's going to run this turn the light on and off sequence a number of times. The way that works is the count starts at 0 and it adds until it gets less than the number. What's the number? The number is generated by the random number generator. And I limited our options between 1 and 5 because, I didn't want to have to like sit through 60 blinks. The point of the proof of concept is here. This works. It works. And then it prints your output, prints that value here. It would seem that you would want this count to equal the number, but when you do that, it just never stops beeping. Even though it says less, that when the count is less than the number, it stops at the number. So like here, that was 3. It said 3. 1, 1. So it's not like it stops at, 2 if you get 3. It works. Why it's supposed to be less than number instead of equals number, not 1,000% sure, but it's not. If you make it equals, it just chimes and chimes and never stops. So over here, this is the other one. So I uploaded these codes separately to each board. They're not like in direct communication currently. Like I say, we're at 7 hours of this. I'm not trying to figure that out just right now. Although maybe for the final, I will do that. But for now, we're just trying to get this to work. So anyway, over here, we've got basically just one integer up here for the speaker box. That's not true. There's another integer or whatever, but it's down here just before we analog read. But basically, speaker box is an output. So yeah, so our loop is we want to get an analog reading at pin A1, analog read A1, and if the voltage is greater than or equal to 600, not volts, but whatever Arduino represents that voltage as. If it goes less than that, then the speaker will make this chime for half a second, and then we want to read that pin again, just to make sure that it doesn't just keep going and going and going indefinitely, because it needs to recheck itself, because otherwise it just maybe assumes it's on, and once it's on, it just stays on. So, and then we put an else function. So, if it's less than 600, go basically chime, and otherwise don't chime. Basically, we got over here, and so yeah, there you go. Pretty cool, actually. That was, if it wasn't stress for the lack of time for the other stuff I got to do, I would think that was a lot of fun. No, it was a lot of fun. It was pretty sweet. And we got it to work, most importantly. So, all right, that's all we're going to do for now. That's going to have to do these. I'll try to code up a little bit, but there's only so much I can do. there's more I can do, but yeah. Okay. Well, anyway, you'll see what you see when you see it. Hopefully it's hopefully it doesn't get me a terrible bad grade. So, alrighty, we'll see you, Mike. Have a good one. Bye.